Hi there, Mr. Sutton here, bringing you the Pre-Cal Honors 8.3 Extra Practice Number 2 solutions on infinite geometric series. For this calculator problem, we're given this weird function f of x equals this craziness here, basically the infinite sum from 1 to infinity of sine squared of x to the k power, and they want f of 1. Well, if you're not really sure what to do, and they give you the f function and they're asking for f of 1, you can start by just plugging 1 into this function. If we do that, we have the infinite series from k to infinity of sine squared of 1 to the k power. Now, we could go a little bit further on this. I mean, we can't just plug this in the calculator because you can't plug infinity into the calculator. But what we can do, this sine squared of 1 is actually a constant. So you're just taking this constant, whatever it is, and multiplying by it over and over and over again. So that means we've actually got a geometric series here, and it's an infinite geometric series. So in order to find the sum of this infinite geometric series, we're going to have to use our a1 over 1 minus r formula. To get that, we need a1 and r. Our first term, a1, that's going to be what you get when you plug the lower limit of summation, 1, in for the k up here. So if you plug 1 in up here, we get a1 just equals sine squared of 1. So nothing terribly fancy. Now the r value, that's what you keep multiplying by over and over again. Generally, that's whatever's being raised to the k power, and that also happens to be sine squared of 1. All right, well, now we just have to plug all that into our formula here. But before we do that, just in case you're wondering if this converges or diverges without looking at the answer choices, the quick way to figure this out, we want to figure out basically if r, the absolute value of r, is less than 1. We know that the sine of 1 is going to be less than 1 because we're not going to get to 1 with sine until you get to pi over 2, which is about 1.5 and change. So sine of 1 is somewhere between 0 and 1. I'm not sure exactly where, but it's somewhere in there. That means that sine squared is also between 0 and 1. So that means that the absolute value then of our r value is less than 1, meaning we know for certain that this thing is going to converge. All right, so now that we've got that, we can just plug the a1 and the r into our infinite sum formula here. So that's going to be sine squared of 1 over 1 minus sine squared of 1. And if you look at the answer choices, you actually have to plug this into your calculator, so let's go ahead and do that. To do this on the calculator, I'm going to do alpha and then y equals, and then this n over d fancy fraction form. So now I've got a fancy fraction, don't have to worry about parentheses. Sine squared of 1. What's really going on here to do this on your calculator, you need to take the sine of 1 and then square all of that. So I'm going to open a parentheses. I'm going to do sine of 1, close that, and then I'm going to close all that and square that. So there's my squaring button here. And just real quick, I'm going to go to mode and make sure that I'm in radians. I am, because if you're not in radians, this is not going to work. All right. Let's go down now to the denominator, and I've got 1 minus, and then I'm going to do what I did before, parentheses, sine of 1, close parentheses, square it, press enter, and hope for the best. About 2.426. So that happens to be answer choice D. On this problem, we have a geometric series from 1 to infinity of an, where they're not telling us a whole lot other than that this an term is always going to be greater than 0. And they're telling us the first term is 48 and our third term is 12. Based off of this, we want to know which statement about our series is going to be true. So choices A and B, we have specific values that this evaluates to. Choice C, this thing converges, but we can't figure out the sum. That's probably a cop-out answer, but we'll check it out later on. And then choice D, this outright diverges. So we need to figure out a few things here. We already know A1, so that'll be useful if we're actually trying to find the sum if this thing converges. But we need to find the common ratio before we can figure out if it even converges or not. So to find the common ratio, normally you would do a term divided by the term right before it. But we don't know what A2 is. We know what A3 is. So here's another way to get around this issue. We know that to get from one term to the next term, you have to multiply by r. So to get from A1 to A3, I have to multiply by r twice. So we can then write A1 times r squared is going to equal 12. which is to say 48 times r squared must equal 12. So this is our starting point for figuring out what that common ratio is that gets us from 48 to 12 in 2 steps. And now the rest is just algebra here. Dividing both sides by 48, 12 over 48 is 1/4. And then if we square root, we can say r equals 1/2. Now you might be thinking, well, hold on a sec. Couldn't r also be negative 1/2? Well, it can't, because that would mean we'd have some negative terms, and they told us in the beginning that an is always positive, greater than 0. So we know for a fact that this is positive 1/2. All right. Now, positive 1/2 or negative 1/2, either way, the absolute value of that is less than 1. That means we know for a fact that this series converges. So choice D is no good. Now the next question is, do we have enough information to figure out what it converges to? Well, to do this, we need to use our formula here, a1 over 1 minus r. We know what a1 is. We know what r is, so we definitely have enough information to figure this out, and choice C is no good either. So it's down to A or B. So let's plug in our numbers here. We have an a1 they told us of 48 over 1 minus the r value we found, which we know for a fact is positive 1/2. That's going to be important on this one. So we've got 48 over 1/2 essentially. That means we're really just multiplying 48 by 2 to get 96. So that's choice B. On this problem, I'm going to start by recognizing that this is a geometric series. That's going to help me figure out if it converges or diverges. And also, while I'm at it, we can just point out that our a1 value is 1, that first term there. So the r value on this one, the common ratio, the thing we're multiplying by each time that tells us this is a geometric series, that's going to be 1/3. If you do 1/3 divided by 1, it's 1/3. Multiply 1/3 by itself, you have 1/9 times another 1/3 is 1/27. Definitely 1/3 for the r value. Absolute value of that is less than 1. That tells us that this series is going to converge. So that means we can actually figure out the sum using s equals a1 over 1 minus r. So that's going to be 1 over 1 minus 1/3. Our a1 is 1. R value is 1/3. So that comes out to 1 over 2/3. Same change flip, we really have 1 times 3 over 2, or just simply 3 over 2. On this one, we're trying to figure out if this is converging, and if it is, giving its sum. So it's a geometric series. We're definitely multiplying by the same thing over and over again. A1 value on this is 1. The r value, what we're multiplying by each time, looks to be 1/5. If you divide any of these things by the thing before it, like 1/5 divided by 1, it's 1/5. Absolute value of that is less than 1, which means that this does converge. So we can figure out the sum using a1 over 1 minus r. So that's going to be 1 over 1 minus 1/5. That's really 1 over 4/5. Same change flip, that comes out to a value of 5/4. On this problem, we want to know if the series converges or diverges and what the sum is going to be if it does converge. So this is a geometric series. We're multiplying by the same thing each time. We have an a1 value of 4, so we might need that later. R value, we've got negative 8 divided by 4, which tells us that we are multiplying by negative 2 each time to get the next term. Now the absolute value of this, and that's the key here, it's the absolute value we're looking at, of negative 2 is greater than or equal to 1. Positive 2 is greater than or equal to 1. That means that this series is going to diverge because these things just keep getting further and further away from a central number. So this is going to infinity in both directions. So we can't actually find the sum, and this problem is just over. On this problem, we're looking to see if we're converging or diverging with this summation, and what the sum would be if it was converging. So let's see here. We got a geometric series. This 2/3 to the n tells us that we're multiplying by 2/3 over and over again, so this is geometric. A1 value, that's going to be what you get when you plug in the lower limit of summation, which is 0 in this case, in for n. That's 5/4 times 2/3 to the 0. Well, 2/3 to the 0 is just 1, so this is really just 5/4 when all is said and done. The r value, that's what we keep multiplying by over and over. That's the 2/3 in this one. And 2/3, the absolute value of that is less than 1, So we are converging on this, and we can actually go ahead and calculate the sum of the infinite series. So that's going to be S equals A1 over 1 minus R. So in this case, that's 5/4 over 1 minus 2/3. This is 5/4 over 1/3. Same change flip, we're doing 5/4 times 3 over 1. So that's going to be 15 over 4. And that's it for this one. On this problem, we want to know if we're converging or diverging and what the sum is. So this one is kind of a mess. I mean, we have the nth sign for each of the terms of pi over 4 plus n times pi. So it would be very helpful on this one to actually write out a few terms of the series and see if we can look at what we're actually getting when we do all this craziness. So I'll start by plugging 0 in for n. That's, let's see here, pi over 4 plus, that'll just be 0. So we're doing basically sine of pi over 4 to the 0th power, because that's what this n here is doing, is it's taking the sine of all this stuff and raising it to this power. So anything to the 0 is just going to be 1, so that's just 1. Next, we've got 1 for n, so this is just the sine, the regular sine of this stuff. Pi over 4 plus pi, that's 5 pi over 4, which is, let's see here, 225 degrees essentially. Sine of that is negative root 2 over 2. If we remember our unit circle magic here, we have a reference angle of 45. We're below the y-axis, or the x-axis, below the x-axis. So that ends up being a negative root 2 over 2. And then the next thing here, if we plug in 2, so that's going to be, let's see here, pi over 4 plus 2 pi. That's essentially 360 degrees plus another 45 degrees, which gives us basically 45 degrees again. It's coterminal with 45 anyway. Sine of 45 is positive radical 2 over 2, but we're also squaring it because we're plugging in 2 for n. So we've got root 2 over 2 plus that squared. And then the next one here, that's going to be plugging in a 3. So this is going to be essentially taking us 45 degrees below the x-axis again, past the 180 line. So that's going to be back to negative radical 2 over 2, and we're cubing it. And this pattern just keeps continuing. All right, so looking at this, we definitely do have a geometric pattern here. We have an A1 value of 1. That's the first term there. The R value, we're multiplying by negative root 2 over 2 each time. And the absolute value of that is going to be less than 1. Root 2 is less than 2, so this comes out to something less than 1. So this means that we do have a converging series, and we can calculate the sum. That's going to be A1 over 1 minus R in general. So in this case, we have 1 over 1 minus negative radical 2 over 2. So 1 plus radical 2 over 2 then. And I'm going to try to simplify this, so let me combine this into one big fraction downstairs. I'm going to think of this as 2 over 2 plus root 2 over 2. So that's going to be 2 plus root 2 over 2. And then if I just do one more step and multiply by the reciprocal, this is just coming out to 2 over 2 plus radical 2. I guess if I really wanted to, I could multiply this by 2 minus root 2 over itself and get rid of the radical in the denominator, but we're not going to go that far. We're calling it done here. On this problem, we want the common ratio of an infinite geometric series with a sum of 32 and first term 16. So let me start by writing the infinite sum formula, S equals A1 over R. We have an S value that they gave us of 32, and that equals an A1 value of 16 over 1 minus R. Now we're just solving for R, the common ratio. So multiplying both sides by 1 minus R, this is going to be 32 minus 32R equals 16. Subtract 32, that's going to be negative 16. Dividing by negative 32, negative 16 over negative 32 comes out to 1/2. For this one, we want an R value for which this series converges to 5. Now the key here is that this is an infinite series, and it's also an infinite geometric series. This R value, this common ratio, raised to a variable power, We're multiplying by the same thing over and over again. So since this is geometric and it's infinite, I can use the infinite geometric sum formula to unravel what's going on here. So I have S equals A1 over 1 minus R. Now we have an S value, a sum of 5. Whatever the series converges to is the sum of the series. So that's 5 equals, well, if we're looking for R, that means we better figure out something to plug in for A1. So A sub 1, that's the initial term. That's the term you get when you plug in the lower limit of summation, which in this case is n equals 1. So if I plug in n equals 1 here, this is R to the 0 power at that point, which just becomes 1. So we're just left with 13 over 2 for A1. And that's still being divided by 1 minus R. All right, so multiplying by 1 minus R, we've got 5 minus 5R. And then to get R by itself, first I have to subtract 5. I'm going to think of 5 as really being 10 over 2, 10 halves. 13 halves minus 10 halves is 3 halves. Now we're just dividing both sides by negative 5 or multiplying by negative 1/5. Either way, this comes out to negative 3 over 10, which will be our final ratio answer. For this problem, if x and y are non-zero real numbers and the absolute value of x times y is less than 1, we want to know the sum of this crazy-looking series. So the key on this one that allows us to figure out the sum, if you look closely here, this is an infinite series. I mean, they said infinite, but the infinity up there indicates it too. And it's also a geometric series. X and y are constants. They're real numbers. They're not telling us what they are, but they're not variables. N is the variable here, which we know because they wrote n down here below the summation. So x and y, we're treating those as constants, and they're being raised to a variable. That means we're multiplying by xy over and over, which makes this a geometric series. So if it's geometric, we can find the summation if we know the initial term and the common ratio. So on this one, my initial term, that's going to be what I get when I plug in 1 for n. That's going to give us xy to the 0 power, which all just becomes 1, which means we just have 1 times 5x squared. So our initial term then is just this 5x squared. That's our a1. It's a weird-looking a1, but again, x is being treated as a constant that we just don't know the value of here. All right, so how about the common ratio? Well, we're multiplying over and over again by xy because we have this variable exponent. So r then is xy. And the absolute value of xy, we know, they told us up here, is actually less than 1. So that tells us that this is a converging series and we can actually find the sum. Now, this is multiple choice and they didn't have an option for there is no sum. So we already kind of knew going into this that we'd be able to find the sum, but it's nice to get the confirmation that this is going to be a thing. All right, so we're going to use our formula. S equals a1 over 1 minus r. a1 in this case was 5x squared. R was just xy, so we have 5x squared over 1 minus xy. And let's look at the answer choices. Let's see here. We need a 5x squared. The only answer choice with 5x squared in the numerator is choice C. And we have 1 minus xy down below, so choice C it is.